Electrical circuit analysis subject. Circuit analysis subject B and B Tech students and first year student subject. In this subject we see university syllabus transient analysis. Another name time domain analysis. First name is transient response analysis. Problem circuit problem. In this class we see class number 92. We already taken transient response class number 86 to 92. Kindly see statement of transient response. Problem circuit theory transient response analysis. Problem coil of inductance 0.4 henries and resistance 10 ohms is connected to a 100 volt constant voltage supply. A. Calculate the rate of change of current at the instant of closing the switch. B. The final steady state of the current. C. Time constants of the circuit. D. Time taken for the current to rise off of the final value. E. The energy stored in magnetic field in joules. That is transient response analysis, Unit 3, Anna University syllabus. In this circuit, resistance and henries, that is inductance and volt supply are given. So that is oral circuit. Draw an oral circuit. Solution. Draw an oral circuit. Source supply 100 volt, resistance or 0.4 Henry. We already explained how to take formula. Current is put I of t or I of t plus L into di of t divided by dt is Vt. That is transient response analysis formula. At t equal to 0, put t 0 plus or I of 0 plus L di of 0 plus divided by dt is Vt. Above formula is obtained. Previous classes I explained. Class number 87 to 92C at man engineering length. Question A part asks calculate the rate of change of current at the instant of closing the switch. At the instant of closing the switches I already explained, that is t of 0 plus. So di rate of change of is mean di of 0 plus divided by dt. I already explained that di of 0 plus divided by dt is formula is V divided by L. V is given 100. L is given 0 plus J4. That is complex format. I already explained in previous mathematical function how to compress to polar and polar to rectangular changes in using calculator. I explained. Kindly see previous classes at math and dA 0 plus divided by dt 100 divided by 0.4 angle of 90 degree. That is answer 250 ampere per second. A part answer. And B part asks the final steady state of the current. ISS we obtained from slope of the graph. Previous class explained V divided by or 100 divided by 10 ampere we obtained. Tau, that is time constants of the circuit. C. We already obtained formula. Time constants for oral circuit. Tau is L divided by R. That is put to record value obtained. Tau is 0.04 second. That is answer. A part, B part, C part answer is obtained. Formula is I explained in previous classes. D part is given. D part is given time taken for the current to rise off of the final value. Take the current off of final value. So I steady state current is 10 ampere. Off of the current is 5 ampere. So take I of t, time taken for the current to rise off of the final value is steady state value is 10 ampere. So 10 divided by 2, 5 ampere. That is important question is given. I of t is formula. We derivated total response V divided by R into 1 bracket of 1 minus e power minus R divided by L power L into T. E power minus R divided by L into T bracket. We already explained in previous classes. Put record values. I of t is 5 ampere. V is 100. R is 10. 1 minus e power minus r is 10 divided by L is 0.4 into t. From these equations, using calculator or exponential method, using mathematical function, find t value is 0.008 second. D is found out. D question is time taken for the current to rise off of the final value. So time is found out. Then go to E solution. The energy stored in the magnetic field. Ask questions. Energy stored in the magnetic field in joules. That formula is given I square L divided by 2 joules. That is formula for energy stored in the magnetic field. I square L divided by 2. Put I value. I is 10. Steady state current N square into L is 0.4 Henry divided by 2. We obtain answer. Energy stored in the magnetic field in joules. That is in joules values. The energy stored in the magnetic field formula is I square L divided by 2 joules. That is oral circuit transient response analysis. That is oral circuit transient response analysis. First calculate the di 0 plus divided by dt value, that is v divided by L. Then calculate I steady state value. Then calculate time constant tau. Then calculate taken I of t is 5 ampere. Calculate time. Then calculate energy stored in the magnetic field in the joules. That is university third semester, third unit syllabus. Thank you.